All right, this is the part 2 of momentum in 2D problems. So we're going to start with number 38. So we have to know, like from the previous video, that momentum is conserved whether it's in one dimension or two dimensions. So in two dimension, it just means that momentum is conserved in both directions. So in the x direction, the total momentum before the collision or explosion has to be equal to the total after in the x direction. And the same thing applies for the y direction. So we're going to start with some simple ones here, where the two objects are moving at a 90-degree angle to each other. So you have a 60 kilogram moving at 5 meters per second east. So the total momentum of that is 300 kilograms meters per second. It's tackled by a 40 kilogram free safety going north. So I'll put the 300 down here. So the momentum of this one is 400. Okay, I always start with the east and west first, and then I do north and south second. And the reason for that is because when we measure the angles, we always measure them with respect to east or west. What is the magnitude of the final momentum of the combination? Well, this blue arrow here, that's the initial momentum of the combination, and that's also the final momentum of the combination. So now if you do Pythagorean theorem, you should get 500. So P final is equal to P initial because of the conservation of momentum, and that's 500 kilograms meters per second. What is the final speed of the combination? Well, all you have to do is final momentum is the total mass times the final velocity. Okay, so this is 500 equals, when they combine, you have a mass of 100 together times the V. Final, you should get 5 meters per second. Now for direction, you just have to figure out what this angle is here. So I think you can do the inverse tangent or inverse sine or cosine. You can do whatever you want. But this is inverse tangent of 400 over 300. So when they come in at 90-degree angle with respect to each other, it's very straightforward. All right, so let's look at this one here. Okay. So here you have an object moving at 8 meters per second east with a mass of 4 kilogram. So that's a momentum of 32 kilograms meters per second. And then it's going to collide with something going south. So you always do head to tail to make your triangle. Okay, this has 30 kilograms meters per second. What is the magnitude of the initial momentum of each? So we already calculated those. So it's 32 and 30. What's the initial momentum of the system? Well, this is the total momentum of the system. So that's your initial momentum, which also is going to be the same as your final momentum. So in order to figure out this P initial, you just have to do Pythagorean theorem in there because that's a right triangle, and you should get 43.86 kilograms meters per second. And to find the direction, you just have to find out what this angle is here. So you can do an inverse tangent of 30 over 32. And you should get an angle that's south of east. So that's 43 south of east. Okay. And what's the final velocity of the two bodies if they stick together? So now we're just going to say, well, the final momentum is the total mass times the velocity of the combination. Now the final momentum is the same as the initial momentum. So that's 43.86. The total mass is 10 and times VF, and you can just divide, and you should get 4.39, it looks like. And the angle is going to be the same angle because momentum is mv. Okay, so the direction of momentum and the direction of v are the same because the mass is positive. So when you multiply a vector by or divide a vector by a positive quantity, it does not change the direction. All right, number 40. A 10 kilogram body moving at 4 meters per second east collides with a 3 kilogram body going at 7 meters per second north of east. Okay, so let's see how we can draw this. So the first one is going east and it has a momentum of 40. Okay, collides with a 3 kilogram object moving at 7 meters per second in this direction here. This angle here is 30 degrees. The momentum here is 21. Okay, what's the magnitude of the initial momentum of each body? I think we just calculated this. So it's 40 and 21. Yep. Okay. What is the initial momentum of the system? So basically we have to find this red arrow here. And that's the initial momentum, which is also the final momentum. Because momentum has to be conserved in magnitude and in direction. So I think in here we can do two things here. We can do the chart method, we can make a chart, or we can do a law of cosines. So the chart method is in the answer key, but I'm going to do the law of cosines for this case here. Okay, so the initial momentum and the final momentum are going to be the same. So if you find one, you pretty much have the other. So if this angle is 30, this angle here is 150. Okay, so now we can say PO, which is the same thing as P prime, equals square root of 21 square plus 40 square minus 2 times 21 times 40 cosine of the angle facing what you're looking for, which is 150 degrees. And here we should get 59.13. Okay. No, not degrees, kilograms meters per second. Now we have to figure out this angle here. Now here we do law of sines. So sine theta over 21 is sine of 150 over 59.13. And that should give us an angle of 10.23. Now, whenever you're doing law of sines, you have to make sure that the angle you found makes sense. So if I put 10.23 here, that's 150. So I'm left with about just roughly 20 degrees here. So we have to check that the triangle makes sense. So you have a 10 degree here, you have a 21 across from it, you have a 20, you have a 40 across from it, 150, and you have a 59 across from it. So the triangle makes sense. If it doesn't make sense, you have to pick the supplement of 10 degrees, 10.23. Okay, so this is just going to be 10.23 north of east. Okay, so the initial and the final momenta are going to be 59.13 kilograms meters per second at 10 degrees north of east. Okay, and to find the final velocity, okay, the direction is still going to be 10 degrees. So to find the final velocity, you just take your momentum and divide it by the sum of the masses. So you take that 59.13 and you divide it by 13 kilograms, because when they combine, they become 13 kilograms. And you should get an answer of 4.55 at the same angle. Okay, so you can look at the answer key and you can see how I did it with the chart. So you can break it up into X and Y components. All right, a 10 kilogram ball moving east grazes a stationary 4 kilogram ball. All right, so you have something go 4 kilogram here, moving east, and the other ball here is stationary, right? Not moving. Now your total momentum has to be east. Okay, so that means total momentum before the collision and the total momentum after the collision, they both have to be equal and both have to be east. The incident ball moves off at 15 degrees, at 15 meters per second, at 53 north of east. So this one here moves off with the momentum of 60. And this angle here is 53 degrees. And the other ball goes off at 20 meters per second, so that's a momentum of 80. And this angle here is 37. So now we can add these two together, right? And the combination of these two here, these two momenta here, has to be east. So it doesn't matter which one I do first. So if I do the 60 here, okay, I come to the head of the first vector and I draw the second one, but the combination has to be east because the total was east before the collision. So this is 60, this is 80. This angle here is 53 degrees. Okay. This angle here is 37, which makes this angle here 37, alternate interior. So these two add up to 90, which means this is a 90-degree angle. Now it makes it easier because now it's just a right triangle, and you should know how to deal with this. Okay, so now if you want to find this momentum here, which is the initial, and also it's the final momentum, okay, so we can just do Pythagorean theorem, and you can find that P initial is the same as P final, and that should give us 100. Yeah, it's 60, 80, that's 100 kilograms meters per second. Okay, and it was going east. Now to find the speed, it's just 100 divided by the mass of the first ball, which is 4 kilograms. So it should be 25 meters per second east. So it's extremely important that you realize that the final momentum has to be going east, because the total momentum before the collision was east. Okay. A 20 kilogram moving object explodes, right? A 5 kilogram piece goes off at 8 meters per second at an angle of 50 degrees north of west. So here's a 20 kilogram object. We have no idea which way it's going. Okay, and with what speed it was moving. Now a 5 kilogram of the 20 kilograms moves off at 8 meters per second at an angle of 50 north of west. So the momentum of that is looks like it's 40. Okay. Now the remaining 15 kilogram piece goes off at 4 meters per second at 20 degrees north of east. So the other piece, 15 kilogram piece, is traveling this way, and this angle here is 20 degrees. Okay. So that's 15 times 4, so the momentum of this guy here is 60. Okay, what was the velocity of the original 20 kilogram object? Now, the final momentum of these two here after the explosion has to be equal to the initial momentum of the 20 kilogram ball before it exploded. So I'm going to make a triangle here with these two, with the 40 and the 60 as the components of the resultant. So I can start with the 60 or I can start with the 40. It really doesn't matter. So if I start with 60 here, and I just put the 40 here, I mean not drawn to scale obviously, 40 here, this is the resultant. And this is the initial momentum of the 20 kilogram ball before the explosion, and it's also the final momentum of the combination. So let's see how I'm going to do this with law of cosines again. If you wanted the chart method of doing this, you can just look at the answer key. So this is 20 degrees here. Okay. And this angle here is 50. Okay. If this is 20, this is also 20 Those are alternate interior, so which means 50 plus 20 is 70. So this angle facing the initial, the final and the initial momentum has to be 70. So that's a 70-degree angle. So now I think I can do law of cosines and find the initial slash final momentum, because they're going to be the same. And that's going to be 40 square plus 60 square minus 2 times 40 times 60 cosine of the angle between them, the included angle. I need to take a radical here. And that should give us 59.65 kilograms meters per second. Okay. Now to find the velocity, you just take that number and divide it by the mass, which is 20 kilograms, and you should get 2.98 meters per second. Now let's figure out the angle. Okay, so I'm going to try to figure out this angle here. This angle here, theta, right? So before I can figure out that angle, I think if I can get my hand on this angle here, let's call it alpha, then I can just see that theta plus alpha plus 20 is 180, and then I can figure out the angle that I'm looking at. Okay, so let's see. I'm going to do law of sines. Sine of alpha over 40 is sine of 70 over this leg here, which is 59.65. So this angle here is going to be sine of 70 times 40 divided by 59.65. And we take an inverse sine. All right, so this angle here is 39 degrees, about 39 degrees. Okay, so now let's see if this makes sense. So if I put 39 here, so that's going to be 109, so that's going to leave me with 71 degrees here. So let's see if this triangle makes sense. So you got 39 degrees, it's got a 40 across from it, the 70 has 59.65 across from it, and 71 degrees has 60 across from it. So the triangle makes sense. If it didn't make sense, you will have to use the supplement of 39 degrees. Okay. All right, so if this is 39 degrees here, okay, so this angle theta here is 180 minus 39 minus 20. So what is that going to be? (180) minus 39 minus 20. Got 121 degrees, right? Which doesn't make sense because now I should be on the other side. I just put my drawing in the wrong side here. So how far off am I from this line here? So I have to be 121 degrees on the other side. Okay, so the angle should be about 60 degrees, or roughly 60 degrees. So 59 degrees actually, yeah, okay? Because this doesn't make sense, right? Let's do it this way. This here is 121 degrees, okay? So which means this angle here is 59. Okay, just based on how I drew it, right? So if I had drawn it like going up this way in the beginning instead of going this way, I would have just gotten the right answer from the beginning. Okay. So it's not 121, but it's 180 minus 21. It's the supplement, in other words. Number 43. Okay, a 10,000 kilogram truck moving west at 25 meters per second. So the momentum of that is 2, 5, and 4 zeros. Collides with a 7,000 kilogram van moving south. So head to tail again. So that's going to be 1, 4, and 4 zeros. Okay, that's the momentum of the van. If the two vehicles stick together, find their speed and direction after the collision. So now we go into like easy stuff now. So the momentum of the initial momentum is equal to the final momentum. So I think if I can find the initial momentum, I pretty much have the final momentum. So if you do a Pythagorean theorem here, you can figure out the momentum. So that's going to be 286,530. Point some change, 0.98 kilograms meters per seconds. And that's the initial momentum. That's also the final momentum. All right, now to find the angle, you just have to figure out that angle by doing a little bit of a simple trick. To find the speed, you just have to take this number and divide it by 17,000 when you combine the two masses together. And you should get about 1685. Okay, 44. A 50 kilogram scale is traveling due east at 3 meters per second, so a momentum of 150. A 70 kilogram scale is moving due south at a speed of 7 meters per second. So the momentum of this one is 490. Okay, they collide and hold on to each other, so they stick together. Okay, we need to find the angle of the combination. So this is the initial momentum, but it's also the final momentum. So we have to figure out this angle here, and we have to figure out the length of this vector here, right? Once we figure out the length of this vector here, we can just divide it by 50 plus 70, which is 120, to get the speed of the combination after they stick together. So this is pretty straightforward, I think.